Dear students, today we will start the topic general solution from trigonometric functions. First, we will see the definition of general solution. What is the definition of general solution? The solution of a equation which is generalized by using its periodicity is called the general solution. We know that all the trigonometric functions are periodic functions and we get infinite number of solutions. So, to collect all that solutions in one bunch, in one formula, we generalize that in one formula, and that generalization is called general solution. That is solution of trigonometric equation which is generalized by using its periodicity is called general solution. For example, all solutions of the equation sin theta is equal to half are pi by 6, 5 pi by 6, 13 pi by 6, and here negative 7 pi by 6, like that, etc. up to infinity. Now, all these solutions are generalized in a simple equation, and that equation is n pi plus minus 1 raised to n into pi by 6, where n belongs to z. Means all that solutions are generalized in this formula. Where n belongs to z means n is integer. Z is set of integer. N belongs to z means n takes value on your number line 0, plus, minus 1, like that. Plus 1 minus 1, plus 2 minus 2, and all that. Okay. Now, the solution n pi plus minus 1 raised to n into pi by 6, n belongs to z, is called general solution for sin theta is equal to half. Now, it is clear to you what is meant by general solution. Due to periodicity, we get infinite number of solutions for all the trigonometric functions, and the solutions are collected in one of the formula or generalized in a formula, and that solution is called general solution. Now, we will see some formulae. You know that all the trigonometric functions have different values. Now, for example, for sin theta is equal to 0, what we will get? General solution for sin theta is equal to 0. All the infinite solutions are collected in the formula theta is equal to n pi, where n belongs to z. Means for the function sin theta is equal to 0, all the solutions are in this formula theta is equal to n pi. Therefore, for sin theta is equal to 0, theta is equal to n pi is the general solution. Again, for cos theta is equal to 0, what is the general solution? For cos theta is equal to 0, see, if cos theta is equal to 0, this implies theta is equal to 2n plus 1 into pi by 2, where n belongs to z. Means for cos theta is equal to 0, theta is equal to 2n plus 1 into pi by 2 is the general solution. Means if the functions are of the type theta is equal to 0, sin theta is equal to 0, cos theta is equal to 0, tan theta is equal to 0. In this case, for sin theta, general solution is theta is equal to n pi. For cos theta, general solution is theta is equal to 2n plus 1 into pi by 2. And for tan theta is equal to 0, we get theta is equal to n pi as a general solution. And all these functions are similar, equal to 0. Therefore, they have collected in the remark 1. I have given you they in the remark 1. Okay. All these remarks are nothing but the theorems in your previous syllabus. In new syllabus, these are given as a remark. In previous syllabus, These are the theorems, but you don't worry about that. You only remember these as a formula. This remark 1 as a formula. Now we will consider the second remark. See, in your new syllabus, this sin theta is equal to sin alpha. If the trigonometric function is of the type sin theta is equal to sin alpha, then that implies that general solution for this function is theta is equal to n pi plus minus 1 raised to n into alpha, where n belongs to z. This is given as a theorem in your textbook, but you remember this only as a formula. In my 20 years experience of teaching, such type of theorems never asked in the exam. Therefore, you don't worry about the proof. You only remember this as a formula. Now, if cos theta is equal to cos alpha, if the function is of the type cos theta is equal to cos alpha, then this equation implies that theta is equal to 2n pi plus minus alpha. N belongs to z. Means the equation is of the type cos theta is equal to cos alpha. Then general solution for this function is theta is equal to 2n pi plus minus alpha. Now, what about tan theta is equal to tan alpha? If tan theta is equal to tan alpha, then general solution for this function is theta is equal to n pi plus alpha, where n belongs to z. See, all these three functions are similar type. Sin theta is equal to sin alpha, cos theta is equal to cos alpha, and tan theta is equal to tan alpha. Therefore, these three theorems I have collected as a remark 2. You have to remember this as a formula. First remark as first bunch of formula, and this second remark as a second bunch of formulas. Means total there are, in remark first there are 3 formulae, and here in remark 2 there are these 3 formulae. These formulas are nothing but the theorems, but theorem never asks in exam. Therefore you only remember the statement of theorem as a formula. Okay, we will see the next remark. Now, these remarks are given you as theorem 4, 5, 6, etc. Now, what is this? If sin square theta is equal to sin square alpha, means if the function is of the type sin square theta is equal to sin square alpha, in this case, the general solution of this function will be of the type theta is equal to n pi plus minus alpha, where n belongs to z. Now, the next formula. If the function is of the type cos square theta is equal to cos square alpha, if the function is of the type cos square theta is equal to cos square alpha, for this type of function, the general solution will be theta is equal to n pi plus minus alpha, where n belongs to set of integers. Now, the third formula will be if tan square theta is equal to tan square alpha. If tan square is equal to tan square alpha, this implies theta is equal to n pi plus minus alpha, where n belongs to z. Means if the function is of the type tan square theta is equal to tan square alpha, then the general solution is theta is equal to n pi plus minus alpha. These 3 I have collected in remark 3 because of their similarity, and you remember this as a formula. And very simple to remember that in all these 3 cases the general solution is of the same type n pi plus minus alpha, whether it is sine, cos or tan. Okay, now these 3 remarks, all these 3 remarks contains total 9 formulae, and you have to remember these theorems as a formulae to find the general solution of any functions. If the function is cos, say cot like that, then you have to take the reciprocal of that functions, and using this formulae you are able to find the all general solution of all 6 trigonometric functions. Now, if these 3 remarks that is total 9 formulae are familiar with you, then it is very simple to find the general solution of any trigonometric function. Now let's consider some examples. What is the headline? Find the general solution. First example, sine theta is equal to root 3 by 2. We have to find the general solution of this function. Now, consider your table of 0 to 360 degree. In that table, where we get the value of sine theta root 3 by 2, and you are very much familiar that at sine pi by 3, value of sine function is root 3 by 2. Therefore, write down sine pi by 3 is equal to root 3 by 2. Now, compare these two examples. Sine theta is equal to root 3 by 2 and sine pi by 3 is equal to root 3 by 2. Comparing these two equations, we get sine theta is equal to sine pi by 3. We get sine theta is equal to sine pi by 3. Now, go to your remark where we will get such type of function. Sine theta is equal to sine alpha. This sine theta is equal to sine pi by 3 is in the type sine theta is equal to sine alpha. That is our remark 2. Go to remark 2. There will be the formula sine theta is equal to sine alpha. Means our function sine theta is equal to sine pi by 3 is in the form sine theta is equal to sine alpha, where alpha is pi by 3. Now, if the function is of the type sine theta is equal to sine alpha, then this implies that general solution is theta is equal to n pi plus minus 1 raised to n into alpha. Therefore, you write here, take this function, sine theta is equal to sine alpha implies theta is equal to n pi plus minus 1 raised to n into pi by 3. Keep the value of alpha pi by 3. Here alpha is pi by 3. Therefore, here formula will replace in this formula alpha by pi by 3. Here also alpha by pi by 3, where n belongs to z. Therefore, we get the general solution of sine theta is equal to root 3 by 2 is theta is equal to n pi plus minus 1 raised to n into pi by 3, where n belongs to z, that is set of integer. Now, it is very simple. If formula is in your hand, then it is very simple to find the general solution. We have to go only to your 0 to 367 and find out the value of theta. If theta is found out, then it is very simple. Keep the value in the formula only. Okay. Then we will see the next example. Consider the next example. Cos theta is equal to 1 by root 2. Write down cos theta is equal to 1 by root 2. Now go to your table 0 to 360, where we will get value of cos theta 1 by root 2. At angle pi by 4 we get value 1 by root 2. Therefore, write down here cos pi by 4 is equal to 1 by root 2. Now compare these two equations, first and second. Comparing first and second, we get cos theta is equal to cos pi by 4. Again go to your remark, where we will get the function like this cos theta is equal to cos alpha in the remark 2. Here alpha is here pi by 4. Now, according to our remark 2, cos theta is equal to cos alpha implies that the general solution will be theta is equal to 2n pi plus minus alpha. Write down here simply cos theta is equal to cos pi by 4 here. Means in this equation only we have to keep value of alpha pi by 4. Write down cos theta is equal to cos pi by 4 implies theta is equal to 2n pi plus pi by 4, n belongs to z. Means what we are doing here, only our aim is to find the value of alpha. If alpha is found out, then keep the value of alpha in the formula and it is the general solution. And to keep the value of alpha, first we have to check in which formula or in which remark this type of functions occur. And take that formula and keep the value of alpha. That will be your general solution. Then write down this cos theta is equal to cos pi by 4 is nothing but our problem. Cos theta is equal to 1 by root 2. Write down. Therefore, the general solution of cos theta is equal to 1 by root 2 is theta is equal to 2n pi plus minus pi by 4, n belongs to z. Means in all these examples, we have to check that where that value of functions comes from the table 0 to 360. Then we have second aim is to take in which remark this function will be fitted. According to that remark, take the general value and keep the value of alpha, and that will be your general solution. To more illustrate this, take the next example. Consider tan theta is equal to root 3. Now write down here we have tan theta is equal to root 3. Again, check whether we will get value of tan theta root 3. From your table 0 to 360, we will know that at tan pi by 3, value of tan theta is root 3. Now compare this first and second. Tan theta is equal to root 3 and tan pi by 3 is equal to root 3. Comparing these two, we get tan theta is equal to tan pi by 3. Then our aim is to check in which remark this type of functions occur. See in the remark 2, third formula, third theorem is tan theta is equal to tan alpha. Means this function is of the type tan theta is equal to tan alpha. And if the function is tan theta is equal to tan alpha, then what will be the general solution? If the function is of the type tan theta is equal to tan alpha, then general solution is theta is equal to n pi plus alpha, where n belongs to z. Keep value of alpha pi by 3 in this formula. What we will get? We will get tan theta is equal to tan pi by 3. This implies theta is equal to n pi plus pi by 3, n belongs to z. And what is this tan theta is equal to tan pi by 3? Tan pi by 3 means root 3. Means we get the function tan theta is equal to root 3. That is our problem. Therefore, write down this general solution of tan theta is equal to root 3 is theta is equal to n pi plus pi by 3, n belongs to z. In each step we have to write n belongs to z because n takes the value from the number line 0 plus minus 1 plus minus 2 like that. Okay. Means in each problem it is very simple. If the problem is given, we have to find out where we will get this value. Take that value from the table, compare two equations, find out value of alpha, then check in which remark this type of formula occur, and according to that we have to take the general solution, keep the value of alpha, and finish. Very simple to find the general solution. Consider the next example. Sin theta is equal to minus root 3 by 2. Write down we have sin theta is equal to minus root 3 by 2. Now here the function is negative. Therefore, you don't get the value, negative value directly from the table 0 to 360. Only we will find positive values there. Where do we get value of sine root 3 by 2 in the table 0 to 360? You know that at sine pi by 3, value of sine theta is root 3 by 2. Write down that sine pi by 3 is equal to root 3 by 2. Then take the negative sign of both sides. If I take negative sign of both sides, then I get sin theta is equal to minus sin pi by 3. Now use the allied angle table. Where the sign is minus, in third quadrant sign is minus. From the allied angle table, we take the formula sin pi plus theta is equal to minus sin theta. And we will use this formula. And for minus sin pi by 3, you write down sin pi plus pi by 3 according to this allied angle formula, because minus sin theta means sin pi plus theta. Therefore, minus sin pi by 3 will be sine pi plus pi by 3. Now, after simplification, what will be this angle? This angle will be 4 pi by 3. Means at the angle sine 4 pi by 3, we get negative value minus root 3 by 2. Now compare these two equations, first and second. We have find out where we will get negative value of sine theta, that is minus root 3 by 2. Compare equation 1 and 2. By comparing 1 and 2, we will get sine theta is equal to sine 4 pi by 3. Means we have converted our problem in the form sine theta is equal to sine alpha. See the first formula in remark 2. This is sine theta is equal to sine alpha, where alpha is here 4 pi by 3 and function is of the type sine theta is equal to sine alpha. If the function is of the type sine theta is equal to sine alpha, then what will be the general solution? According to our remark or according to our theorem, sine theta is equal to sine alpha implies that the general solution will be theta is equal to n pi plus minus 1 raised to n into alpha, where n belongs to z. Then what we will get? We will get sine theta is equal to sine 4 pi by 3 implies theta is equal to n pi plus minus 1 raised to n into 4 pi by 3, where n belongs to z. Now the sine theta is equal to sine 4 pi by 3. What is the value of 4 pi by 3? That is minus root 3 by 2. If I keep here value of sine 4 pi by 3 minus root 3 by 2, what I will get? I will get sine theta is equal to minus root 3 by 2. Sine theta is equal to minus root 3 by 2. That is our problem. Therefore, write down here the general solution of sine theta is equal to minus root 3 by 2 is theta is equal to n pi plus minus 1 raised to n into 4 pi by 3, n belongs to z. This is the general solution of our given problem. Means in all these problems, we are converting this function in the standard form which are given in the remark, and then we are finding out the general solution. Consider the next example. Cos theta is equal to minus half. Again go to your table 0 to 360. Where we will get value half? We will get at cos pi by 3, value of cos theta is half. Now take the minus sign of both sides. Take the minus sign of both sides. Where the cos theta is negative, from the allied angle, take the formula cos pi minus theta is equal to minus cos theta. That is in the second quadrant, cos theta is negative. Therefore, for minus cos theta, we can put cos pi minus theta. Therefore, here for minus cos pi by 3, I will put cos pi minus pi by 3. And after simplification, this will be cos 2 pi by 3 is equal to minus half. Now again compare equation first and second. Both have the same values. Right hand side is same. Therefore, equating the left hand sides, we will get cos theta is equal to cos 2 pi by 3. Now, this given problem I have converted into standard form. This is theorem 2 from your remark 2. I have converted this function, this given problem, this function in the form cos theta is equal to cos alpha. Now, if the function is of the type cos theta is equal to cos alpha, then what will be the general solution? If cos theta is equal to cos alpha, in that case, the general solution is theta is equal to 2n pi plus minus alpha, n belongs to z. Now, what is alpha here? Cos theta is equal to cos alpha. Alpha is 2 pi by 3. Therefore, I will keep here alpha, value of alpha 2 pi by 3, and here also value of alpha 2 pi by 3. Then what I will get? I will get cos theta is equal to cos 2 pi by 3 implies theta is equal to 2n pi plus minus pi by 3, where n belongs to z. Then what is this cos 2 pi by 3. See here, cos 2 pi by 3 is minus half. Keep here cos theta is equal to minus half. Then we get our original problem. Means the general solution of cos theta is equal to minus half is theta is equal to 2n pi plus minus 2 pi by 3, n belongs to Z. This is the very simple way to find the general solution. We have to check where that function have this value. We have to take this value from with the help of 0 to 360 table and allied angle table, convert that function into standard form, check in which formula this will be fitted, and according to that we get the value of theta, that is general solution. Keep the value of alpha in that, you will get the required general solution of the given function. Okay, take the next example. See here, we have to find general solution of cot theta is equal to minus root 3. Now, see our remarks. In remarks, formula only for sine, cos and tan. There are no formulae for cot, sec and cosec. Therefore, convert this cot into tan. Take reciprocal of cot, we will get tan theta is equal to minus 1 by root 3. From here table 0 to 360, see where we will get value of tan theta 1 by root 3. At tan pi by 6, value of theta is 1 by root 3. Take minus sign of both sides, we will get minus tan pi by 6 is equal to minus 1 by root 3. Then go to again allied angle table. Minus tan theta means tan pi minus theta. Means here minus tan pi by 6 can be replaced by tan pi minus pi by 6 according to this allied angle formula. I have written here instead of minus tan pi by 6, tan pi minus pi by 6. After simplification, what will be this? This will be tan 5 pi by 6 is equal to minus 1 by root 3. Again compare equation first and second, they have right hand side same. Therefore equating left hand side, we will get tan theta is equal to tan 5 pi by 6 from equation 1 and 2. Now we have converted the given problem into standard form. Which is this form? This is in the form tan theta is equal to tan alpha, where alpha is 5 pi by 6. This is in the form tan theta is equal to tan alpha. This is theorem 3 from remark 2. In remark 2, such type of formula we have collected. Now, if the function is of the type tan theta is equal to tan alpha, then what will be the general solution? General solution will be theta is equal to n pi plus alpha, where n belongs to Z. Then keep the value of alpha here. Compare this equation. See this equation. This is of the type tan theta is equal to tan alpha. Means value of alpha is 5 pi by 6. Keep in this formula value of alpha pi by 6. Value of alpha pi by 6. Therefore, write down tan theta is equal to tan 5 pi by 6 implies theta is equal to n pi plus 5 pi by 6. N belongs to Z. Now, this tan 5 pi by 6 is nothing but minus 1 by root 3. And taking reciprocal of tan theta, we get cot theta, and reciprocal of minus 1 by root 3 is minus root 3, means our original problem. Therefore, write down the general solution of cot theta is equal to minus root 3 is theta is equal to n pi plus 5 pi by 6, n belongs to Z. Now, in all these problems, what we are doing? We are converting the given problem into standard form. And according to that remark, we are getting the general solution and keeping the value of alpha only. To more illustrate this, take some more examples. Consider cosec theta is equal to 2. We have to find the general solution of cosec theta is equal to 2. First, write down cosec theta is equal to 2. Then again, I have told you that all the functions or all the formula in sine, cos and tan form. Therefore, convert this cosec theta into sine. Take the reciprocal of cosec theta, you get sine theta is equal to half. Again go to your table 0 to 360 degree, where we will get the value of sine theta half. At sine pi by 6, value of sine theta is half. You write down that. Then compare these two equations. Sine theta is equal to half and sine pi by 6 is equal to half. Right hand sides are equal. Equate the left hand side. You will get sine theta is equal to sine pi by 6. Now, which type of function is this? This is of the type sine theta is equal to sine alpha. Means this is our first formula, first theorem from remark 2. We have converted this given function into form sine theta is equal to sine alpha, where alpha is pi by 6. Now, if the function is of the type sine theta is equal to sine alpha, then what will be the general solution? General solution is theta is equal to n pi plus minus 1 raised to n into alpha. Now our next step is to keep the value of alpha here and here. And what is alpha? Alpha is pi by 6. Now keep the value of alpha, then we will get sine theta is equal to sine pi by 6 implies theta is equal to n pi plus minus 1 raised to n pi by 6, n belongs to z. And now this function sine theta is equal to sine pi by 6 is nothing but sine theta is equal to half, that is cosec theta is equal to 2. Therefore, write down the general solution of cosec theta is equal to 2 is theta is equal to n pi plus minus 1 raised to n into pi by 6, n belongs to z. In this simple way, very very simple to find the general solution if you know the remarks, that is the formulae. Now take the next example, sec theta plus root 2 is equal to 0. Again we have to convert this into cos. Write down here, sec theta is equal to minus root 2. Take the reciprocal, this will be cos theta is equal to minus 1 by root 2. Now go to your 360 table, where we will get the value of 1 by root 2 at cos pi by 4. Value of theta is 1 by root 2. Now take the minus sign of both sides. You will get minus cos pi by 4 is equal to minus 1 by root 2. Again here value is negative. Therefore we will take the formula from allied angle table. If minus cos theta is the angle, then this angle can be converted cos pi minus theta. That is, this minus cos theta can be written as cos pi minus theta. Therefore, according to this allied angle formulae, this minus cos pi by 4 can be written as cos pi minus pi by 4. Then after simplification this, we will get cos 3 pi by 4 is equal to minus 1 by root 2. Now you compare equation 1 and 2. These two equations have right side equal, therefore equate the left hand sides and you will get cos theta is equal to cos 3 pi by 4. Now we have converted the given problem into standard form. Which form is this? This is cos theta is equal to cos alpha type. And this type of formula are in remark 2. And if the function is of the type cos theta is equal to cos alpha, then what will be the general solution? General solution will be theta is equal to 2n pi plus minus alpha, n belongs to z. Now, here our alpha is 3 pi by 4. Therefore, keep in this formula value of alpha 3 pi by 4. And we will get cos theta is equal to cos 3 pi by 4 implies theta is equal to 2n pi plus minus 3 pi by 4, n belongs to 0. Now, this cos theta is equal to cos 3 pi by 4 is nothing but our given problem, given function sec theta plus root 2 is equal to 0. Therefore, write down in the last step the general solution of sec theta plus root 2 is equal to 0 is theta is equal to 2n pi plus minus 3 pi by 4, n belongs to 0. That is, in each and every function, given function, we are converting into standard form and applying the given formula. Okay. Consider the next problem. Cos 2 theta is equal to minus 1 by root 2. Again write down the equation as it is. Cos 2 theta is equal to minus 1 by root 2. Take that as equation 1. Then go to your 360 table where we will get the value of cos theta minus 1 by root 2 at the angle pi by 4. Cos pi by 4 value is 1 by root 2. Take the minus sign of both sides. Then take the help of allied angle formula. Minus cos theta can be written as cos pi minus theta. Therefore, instead of minus cos pi by 4, write down here cos pi minus pi by 4. Simplify this. After simplification, we will get cos 3 pi by 4 is equal to minus 1 by root 2. Compare equation 1 and 2, you will get cos 2 theta is equal to cos 3 pi by 4. See, again this problem is of the form cos theta is equal to cos alpha. That is second theorem from remark 2. And if the function is of the type cos theta is equal to cos alpha, what will be the general solution? General solution will be theta is equal to 2n pi plus minus alpha n belongs to j. Now, see, this is the different type of function. Here, theta is also replaced by 2 theta. This function is cos theta is equal to cos alpha. Where is theta? Here theta is 2 theta and alpha is 3 pi by 4. Therefore, in this function, we have to replace theta, this theta by 2 theta, this theta by 2 theta, and alpha by 3 pi by 4, alpha 3 pi by 4. This is quite different from earlier problems. Therefore, write down cos theta 2 theta is equal to cos 3 pi by 4 implies 2 theta is equal to 2n pi plus minus 3 pi by 4 n belongs to j. Here, in the next step, you have to divide whole equation by 2 because in the general solution, left hand side should contain only theta. That is, coefficient of theta should be always 1. Therefore, in this equation, I have divided whole equation by 2. And after dividing this equation by 2, I have got here theta is equal to n pi plus minus 3 pi by 8. Therefore, in the last step, I will write the general solution of cos 2 theta is equal to minus 1 by root 2. That is our given problem. You write down that as it is. Is theta is equal to n pi plus minus 3 pi divided by 8. N belongs to j. You remember this step. Don't forget. If there is any coefficient other than 1 here, we have to divide that equation by that coefficient. Here, coefficient of theta is 2. Therefore, I have divided the whole equation by 2 and our general solution will be theta is equal to n pi plus minus 3 pi divided by 8. Means in such type of problem, you don't forget to divide whole equation by coefficient of theta. Means in the last step, coefficient of theta should be always 1. Okay? Consider the next example. Consider tan 3 theta is equal to minus 1. Now, see where we will get the value of theta, tan theta 1. In our table 0 to 360, we have tan pi by 4 is equal to 1. Then again take the minus sign of both sides. Then go to your allied angle table. What is mean by minus sin theta? Minus sin theta is equivalent to tan pi minus theta. Therefore, here for minus tan pi by 4, I will write tan pi minus pi by 4 is equal to minus 1. After simplifying, I will get this angle 3 pi by 4. Now, equate equation 1 and 2. Comparing equation 1 and 2, I will get tan 3 theta is equal to tan 3 pi by 4. Now, we have converted the given problem into standard form. Which form is this? This is tan theta is equal to tan alpha of the type. That is third theorem from remark 2. This is of the type tan theta is equal to tan alpha. And if the function is of the type tan theta is equal to tan alpha, then what will be the general solution? Then in this type of cases, the general solution is theta is equal to n pi plus alpha, where you always write n belongs to z. Then what is here theta? Here in this formula, we have to replace theta by 3 theta, both here. You write down in the next step 3 theta, 3 theta. Now what is alpha? Alpha is 3 pi by 4. Therefore, here we have to keep 3 pi by 4 and alpha 3 pi by 4. Now, we will get tan 3 theta is equal to tan 3 pi by 4 implies 3 theta is equal to n pi plus 3 pi by 4 n belongs to z. Again, see here coefficient of theta is 3. We have to write here coefficient of theta should be 1. Therefore, in the next step, we have to divide whole equation by 3. And after dividing, we will get theta n pi by 3 plus pi by 4. Therefore, write down the general solution of, write down the given problem here. Then the general solution of tan theta, 3 theta is equal to minus 1 is theta is equal to, I have divided this equation by 3. Therefore, theta is equal to n pi by 3 plus pi by 4, where n belongs to z. Means if the functions are of the type 2 theta, 3 theta, you remember that in the last step, we have to divide whole equation by coefficient of theta. Means in the left hand side there should be only theta, that is coefficient of theta should be 1. Okay, consider the next example. Sin 4 theta is equal to root 3 by 2. Write down the function as it is. Sin 4 theta is equal to root 3 by 2. Then where we will get the value of sin theta root 3 by 2? That is at the value of pi by 3. Therefore, write down sin pi by 3 is equal to root 3 by 2. Now compare these two equations. Their right hand sides are equal. Therefore, equate the left hand side and we will get sin 4 theta is equal to sin pi by 3. Means we have converted the given problem into standard form. Which form is this? This is in the form sin theta is equal to sin alpha. Now, if the function is of the type sin theta is equal to sin alpha, then this implies the general solution will be theta is equal to n pi plus minus 1 raised to n into alpha, where n belongs to z. Now, what is theta here? See, here theta is 4 theta. Therefore, in this formula, you replace theta by 4 theta here and here also. And what is alpha? Alpha is pi by 3. Keep here value of alpha pi by 3 and pi by 3. We will get sin 4 theta is equal to sin pi by 3 implies the general solution will be 4 theta is equal to n pi plus minus 1 raised to n pi by 3, n belongs to 0. Now again here coefficient of theta should be 1. Therefore, I will divide whole equation by 4 and I will get general solution of sin 4 theta is equal to root 3 by 2 is theta is equal to n pi by 4 plus minus 1 raised to n into pi by 12, n belongs to z. This is our general solution of the given problem. In this way, in today's lecture, we have seen how to find the general solution of given trigonometric functions. And you have understand that to find the general solution, remark 1, 2, 3 are very important, because these remarks are nothing but the formula to find the general solution of given functions. Means if the table of 0 to 360 are known, the allied angle table is known, and these formulae, that is these three remarks to find the general solutions are known, then it is very easy to find the general solution. In our next lecture, we will see problems depending upon the remark 3. Okay, till then, goodbye, see you.